So in this video, I will be explaining to you on how to calculate GM by obtaining the values of both kg and km. So by the way, I am your instructor, Captain John Ray Serum. So in this subject, seamanship 2A or SIM 2A, stability and trim. So the course outcome number 2 that we have for semi-final and finals is to analyze various critical situations to rationalize courses of action undertaken. So the specific intended learning objective that we have to do in this video is at the end of this session. So the students should be able to calculate ship's transverse stability in various conditions. Okay, so for our introduction, let us define first what is kg, or the height of the gravity, the center of gravity above the base of the keel. So this can be calculated through the formula or simple formula, total moments divided by the displacement. This is the formula. Now, before we can obtain the values of these total moments, since it includes the light ship condition of the ship, so we have this table in which we get or obtain from our stability booklet. So we have here the light ship condition, in which the box items are to be used in our formula to obtain the value of the moment. So in this table, we have here the total weight of the light ship, and then which is 12,938. We have here, and then on the other hand, we have the vertical center of gravity. So both are expressed in meters. So for vertical center of gravity, we have there 12.68. Now, as I have mentioned, these are the values necessary to obtain the moment, since when we say total moment, it includes the light ship condition of the ship, including its light ship displacement and light ship BCG. Now, since it includes the light ship displacement and light ship BCG, we should also include the weights of the ballast tanks, freshwater tanks, and all the tanks that we are using on board. Okay, so in this example that we have here, so this is from our own sheet that I have extracted. Actually, this is an Excel file that I have just shown, or shall I say, I take a picture of it and show it to you so that you might be able to understand it. So in the previous slide, we have there the light ship. Okay, so in this example, we have another light ship displacement and BCG, and then as I have mentioned, the different tanks. In this example, we have the ballast tank, we have the double bottom, and then we have the wing tank as well as after peak tank. Okay, So we have also the BCG. Now, where can we obtain the BCG? Since the light ship BCG is obtained in our hydrostatic table in our ship stability booklet. Now, when we say tank, we have a different booklet for that, no? And that is entitled the tank sounding tables, where you can see here in this example that we have the sounding, no? When we say sounding, we measure how much is the liquid inside the tank, no? And then after that we trace how much would be the vertical center of gravity. Now let's go back to the example, no? So you have here already the BCG, no? So you just need to multiply it to the weights, no? So as to obtain the value of the vertical moments. So once you have already the vertical moments, and you also have here, like for example, we don't have the cargo but only the ballast tank, no? So let's assume that this is the entire weight of the ship. This is the displacement of the ship. You add everything here, including the light ship condition. So like for example, that would be the light ship displacement. So you just need to divide it to the total moments in order for you to obtain the value of kg, or the center, the height of the metacenter, the height of the center of gravity above the base of the keel. Because we have the formula kg equals total moments, so vertical moments, that is total vertical moments divided by the displacement. So again, how did you obtain the displacement? By means of adding up all of these items here, the weight, no? So let's just assume that these are the weights, no? These are just the weights inside, because in the actual we have a lot of weights in our ship that we should consider. Now we have here an example, a problem example. So a double bottom tank when full has its center of gravity at a height of 60 cm, that is above the keel, and hold 380 tons of water. Now the kg of the ship is 9.4 meters and her displacement is 3,700 tons. So when the tank is empty, what will be her kg when the tank is filled? So these are the solutions. So we need to construct a table where we have the weight, the classified weight, BCG, and then the moment. So first we need to input, no, or we need to write down the displacement of the ship. So we have 3,700 tons, and then we have the BCG 9.4. So you just need to multiply this one and obtain the value of moment. So we have 34,780, and then so the weight that has been added to the ship is 380 tons, and its BCG is 0.6 meter according to the problem. So in order for you to obtain the vertical moment, you just need to multiply it. So the answer would be 228. Now we have the weight, the displacement of the ship after the weight has been added, which is 380 tons, and then you just also need to add up the moments. So we have here 35,008. So this is just an example in order for you to fully understand how to use